Hi, everybody, and welcome to another episode of the JUXTCast. It's with me, Malcolm Sparks.
Alex Davis.
Joe Littlejohn.
And Andres Galitz.
Andres is joining us as a special guest, and this week we're going to be talking about the Horizon IT scandal. This is the post office that produced a system in the 90s. It's been very much in the topical news recently, mostly because there was in the first week of the new year, there was an ITV drama and documentary, a sort of 4-part drama, which got everybody kind of talking again about this scandal, which has been going on for 20 odd years. But it really made it real to people, and now it's become a real political news story. So we wanted to talk about this and kind of touch upon some of the learning points that we can, as representatives of or members of the tech industry, and that's something that we've really not. We've not covered a lot of the technical details of this scandal, but I believe it is an IT disaster first and foremost, and I've been kind of tweeting that, and so has Andres. And Andres, you wrote a blog last week about this, and you were saying that before in the chat you've had some kind of negative reaction to this blog. Well, maybe you can explain some of what the blog. We'll put the blog article in the show notes, but if you can kind of give an intro to what led you to write this blog, but also kind of some of the reception that you've received.
Thank you. So, yes, I've been writing about distributed consistency for 8 or 9 years now. It's my stick horse. It's what I do. I'm a distributed systems consultant mostly, and I have a startup in the area. And I find that there's a huge divide between academia and industry. I find that there's very, very little overlap in these questions between the two areas. And my goal was to bring a specific solution to this problem. And I found that it would be useful to explain the shortcomings of the existing platforms or the existing solutions that we all know of. Like, we've all heard that microservices have consistency problems. Why? What are those? Why do they have them? What is inherently true about them? And I'm trying to explain these matters and have discussions with developers around these matters with the wider community doing these articles. So you can guess that I'm trying to be popular because I want people to read it, but this one wasn't very particularly successful in that area. Shockingly enough, it was quite successful with people who work in the field, the strict field, so who work in distributed consistency. I know it did well with the Cassandra developers at Apple, for example, because it hit a note with them. It sort of So the article was mostly about how we keep ignoring the most important aspects of distributed consistency, how we cannot put our heads in the sand and just say, my microservice is my problem and everything else is everything else. So I'm giving examples of that, and I'm explaining why the Horizon scandal is a distributed consistency scandal, although I'm standing on the shoulder of Stephen Murdoch in this regard, who's a professor at UCL. I think he's the original author of the Tor browser, and he spent a considerable amount of time digging into the court proceedings and connecting the dots between technology and what he has heard from the witnesses.
It's incredible that actually most of what I know about the technical details of the system come from those court, those court findings and those minutes, and incredibly, actually, one thing that we were talking about is that the fact that everything was so secret and the lack of transparency. I hope that through things like free software and our kind of open source systems and open data, that we're beginning to learn the importance of not putting everything in kind of like not hiding all the details. And part of the scandal of the IT of the post office system was the fact that the willingness of people to go to every length to cover up and hide the technical details as if they were unimportant, and even to the point that some of the forensic logs were unavailable or deleted, or reports were shredded. Second Sites, I think that one of their reports was told, you've got to shred and destroy all the evidence, and that's shocking. But actually, what I did learn from those court proceedings was, in fact, that the Horizon system was a distributed system. The sub postmasters would have, in their local post offices, would actually have a full computer. That was it. It was an early Windows NT build, and so at the same time that in the 90s, the industry was sleepwalking into distributed computing. PCs were coming out, and we began to just accept that, this is the new way of building stuff. So the old accounting systems would be built on mainframes. There would be COBOL and KICS and these kind of things, to like where we understood things like transactions and atomicity, consistency, isolation, durability. But some of the findings in the court proceedings were things like, when there was a power cut, some of these branches had sort of poor electricity, and when there was a power cut, that every power cut was, cost £200 in the system, or the system lost money, which indicates that those acid principles were certainly not evident in the system, and that other parts of the system would go wrong when they launched. I think the first version of Horizon was just a local one, but when they launched Horizon Online and there was some messaging back to the Fujitsu computers in Reading, that was when the fun really began. That's when the systems really began to fail. Joe, what do you think?
I think it's also sort of worth calling out as well that actually we talk about Horizon as a computer system, and I think a lot of people, it's one thing that you get from reading into some of the reports is that not only is Horizon a quite an all-encompassing word for a very, very large system that involves, we're talking about the hardware of the system, we're talking about a very distributed software system. It's a massive system in and of itself, but also Horizon, as the post office sort of master of record, if you like, was also interacting with lots of other systems. Camelot system for managing lottery tickets, Bank of Ireland systems, co-op systems, various energy companies, the link system for payments and credits and debit cards. So I think, in contrast to maybe sort of, single monolithic, systems of the past, Horizon was almost necessarily a distributed system. The work that had to be done spanned not just the aspects and parts of Horizon, but also many, many other systems that were involved. And so it was almost, it was essential really to see this as a distributed system and to think about all of the possible failures that could arise, when making changes and updates across these disparate systems. That would be essential when tackling a problem of this nature, really. And there was no way to eliminate that distribution, if you like, because of the nature of the problem and the nature of the complexity of all of the tasks that were involved.
Yeah, eventually all systems are going to be distributed if you have to integrate with other things. But that's where I think that's where the hubris came in, and it was a dangerous environment. It was a perfect storm of having sleepwalked into a very massive, complex distributed system, whilst at the same time having all the hubris that the techies and the boffins all get it right. That's that kind of like a Bletchley Park kind of cultural aspect of British society, where there's professional managers who, almost as a badge of honor, are not technical. They just trust it to the boffins in the labs and the white coats, and not willing to kind of get down and understand the problems. But
so when I watched the I think it was the Panorama one done 8 years ago or something, they had someone say that they'd add up their accounts for the end of the day using the Horizon system, and it would say, you've got X amount in your till, and they'd go through an account and go, yep, that's right, and you've sold this many stamps and done this much. This is like the total shortfall or whatever, and it would say, X £1,000, and they'd be like, well, no, that's not true, because I keep accounts, and accounting is not a new thing, right? Like computers might be new at this time, but people know how to keep books, and you have your two sides of the books, and double entry accounting has been standard practice for a long time. So my question was sort of, how did no one say, like, oh, well, yeah, of course we can show you where that shortfall came from, because there are like logs for each transaction on both sides, and we can show you where the balance didn't add up. And how weren't people looking at that? They were just sort of assuming that because things were entered into a computer, and it was either like, oh, the person is taking money from the till, or the computer has like done its side wrong. People just immediately assumed that it must be the person's fault and not the computer's fault, when actually, like, you ask most people if they've ever used a piece of software that worked 100% of the time, they'll probably say no. So it was interesting that.
But it would. When in thinking about this podcast, I was thinking, wouldn't it be great if we could trust computers to the point where we know that any shortfalls were to do with wrongdoing? One of the problems of the Horizon system was that it was also a system of manual. So, for example, it had to deal with cash. So the system would say, Mrs. Perkins, traveller, foreign exchange, coming in, and now open the till, take £20 and give it to Mrs. Perkins. And at that point, an unscrupulous postmaster could take another 20 and put them on the back pocket. So there was definitely scope for fraud on the part of the submerged postmasters. But the problem was that actually, so you couldn't, they didn't know that they couldn't trust the system. So the question is, what was really going on behind the scenes that led to these kind of errors? And there are some things that resonate with me when I've kind of read reports about, there was a war room. There was a kind of, they knew that were loads of bugs in the system, and that they were firefighting, because I've been on IT projects where, don't worry, we'll bring in this project manager to sort out all the problems. And they come in with this Excel spreadsheet of 4,000 bugs, and they just go through, and they treat the whole thing as a war room, and things like whack-a-mole, where you fix one bug and two more pop up. And there's completely chaotic environments. And this is why I laugh whenever I see in the front page of a newspaper just saying software glitch causes meltdown at an airport, because I know that it's not actually as a single glitch. It's actually thousands upon thousands of glitches that are sitting there in the software just waiting to happen. And so it's a bizarre kind of cultural thing that there was any trust in the system. And why you mentioned double entry accounting, because I remember when we were in the early days of JUX, we built our own accounting system, and it never lost money because of this sort of nature of double entry accounting. And it doesn't even, in reading the reports of Horizon, it doesn't seem obvious that even double entry accounting was practiced. It seems very much there were some code lines that they had to add last minute, because they needed to kind of make sure that if somebody taken out some money, they sent a message and they forgot to send a message, and then that was losing money. So the whole thing looked like a complete shambles.
I think the thing about the managers, they sound like cartoon villains by this point, don't they? Like jumping at that. But one thing that made sense of this was that they were building Horizon in large part because the central office distrusted sub postmasters. So the raison d'etre of the whole project was that they want to catch those red-handed. So when the system started, showing the red light, they said, we knew it, right? So we called them red-handed. We have them exactly where they know they've been pilfering the chests for the last 50 years, right? So it was initial bias from their behalf. But the other thing that you mentioned was about so the thing that was particularly toxic in this system is that there were a lot of silent failures. Now, silent failures are the worst kind of failures, because if you have a failure, you're going to look for the problem. But if you don't have a failure, you just have badly working software, it takes forever to figure this out. And the particular problem with distributed systems is that this is common. this is a very, because it's almost as hard to figure out if you're missing something from the system than to figure out if something is a duplicate. Neither are obvious things to talk about. So so these sort of errors are actually very typical of all sorts of distributed system. And sorry, I'm going to shut up in a second, but I actually have built a distributed integrated system at a large-ish Hungarian bank with London standards, where we were building the first middleware back in the late 90s. This was in very early Java EE days, right? And we were doing workflows. And to this day, I shudder to think about the sort of things that we were getting away with. At least we had a central monolith. At least we had a single database, and that database had enterprise hardware underneath it. So it never failed. The hardware never, ever, ever failed, because if it failed, someone pulled out a chest and pushed in another one. So it was incredibly expensive, but it never failed. Right? So we had these sort of safeguards back in those days, but that was for a monolithic system, right? I can't imagine the sort of things that could have gone wrong had we not had a single central Oracle instance, babysitting all these processes and at least making each step one by one atomic and so acid, right?
So if we accept it, it's interesting. So on this topic of the problem essentially being distributed, if we think about this from the perspective of, because I think something that we've discussed when entering this podcast in a way is that it's very easy for us to drift off. And as you say, Andras, we think of these, the managers were, these sort of evil characters in this story. And it's very, I think we had sort of thought when going into this recording, think what can we actually, if we treat this as an opportunity as the kind of technical side of this equation to kind of reflect on what we're doing, it does seem, and I'm sure you've got some, insights into this, Andras. It does seem like one of those fundamental learnings that we can take away is that if you're building a distributed system, whether you're an external vendor that's delivering this system, or whether you're working on in-house software, if you're working with a system that is distributed, there are certain kinds of failure that are in scope. They are essential. They're actually, they're provably part of the system. And so this should be something that we all are doing when we're working on distributed systems, is not trying to treat those as aberrations that necessarily can be eliminated if we just did it right. Of course, no one's going to prepare to say what doing it right means, but if we're just careful, we won't have those things. No, these things are essential failures. They're essential failure scenarios. They should be well understood that any system of this nature will have this kind of problem. And I think if we elevate those, that it's almost like the functional requirements of the system and the what kind of what features we've delivered. We also need to be clear about what bugs have we delivered, what errors have we delivered that actually cannot be eliminated. They require attention. They are possible. And I think that would, this is sort of one learning I think that we can come away with here, is that when we're working on these systems, if they're distributed, there's some science that can back us up here, and it is possible to say these are the features we've delivered, and these are the essential, error scenarios that cannot be eliminated when you're working on a system of this nature. And I'm sure you've done a lot of work, Andras, in exploring and formalizing those.
I don't formalize. I'm just a middleman between academia. Like I do have some ideas that I've implemented around this space, but I don't have anything comfortable to say. The reason I left the city to work on, as in financial contracting, was because I saw the writing on the wall, and I saw microservices coming in, and I remember sitting there because this was about a bit more than 10 years ago when this was just a nascent technology, but I was already made to explain MapReduce, if you remember MapReduce, which was, so I was already made to explain these things to people. And I knew everyone knew that was the future, right? And I was sitting there, it's like, there's no way this will succeed. So I was looking at this problem space, and I was thinking to myself, databases do so much for us. If we just let this go, what is going to replace that? And as soon as I saw that nothing is the answer, nothing is going to replace that, I was shocked to my core. And then I started thinking about how to work in this space to bring more order into these topics. Fortunately, this was no longer the late 90s. So by that time, distributed consensus was already part and parcel. We already used Kafka here and there, not that many places, but we did use that. But the hard part was, well, how do I put this? So putting things together in a system like this is not only hard because you need to figure out which things talk to each other, like you do in an asset system. The reason it's a lot harder than that is because you can have parallelism on top of that. Now, I've never, ever seen a project where they designed for parallelism. I've seen modules talk to each other all the time. I've seen all sorts of failure modes between those modules talking to each other. But the fact that you can have dozens of these processes running in parallel and all the combinations that they could potentially assume needs to be looked after, as in needs to be part of the consideration whether when you decide that the software is correct, is not something that I see done anywhere, ever. Because it's impossible to do. Between you and me, I hope no one else hears this. So there it is. I think there's my professional opinion. I don't think this is being thought about. I saw a lot of problems because this brings up like this. It even brings up security problems if you think about it. Is the example I give in the article that we talked about is that if you don't have strong consistency in the system, and these systems do not have strong consistency overwhelmingly, like maybe here and there, but those are not the systems we're talking about. We're talking about classic LFG microservice systems. They don't usually do strong consistency, which means that they don't usually have an absolute order for the messages, which can easily change the meaning of the message. And whether it does can only be known knowing the state that it can assume, all the state that it can assume. And if you can run 10 of these, which overlap in meaning, then the state is exponential. And so it literally does climb exponentially with the number of threads. So there you have it. I don't think there's a good answer. And the shocking thing is that not even something like, I'm not dissing. The reason I'm using cockroach in this example is because cockroach is the best of the bunch, right? The shocking thing is having a distributed database will not save you. And the reason a distributed database will not save you is because you're also integrating things. By virtue of being an enterprise, you are a distributed system. You have an authentication system, you have multiple SaaSs, you have some things you cooked in-house, you have things which are half between the two. Typical example would be SAP, and there's no way to get them to play nice with each other. And I don't see anyone, even in Silicon Valley, doing this at all.
Like I think in the Horizon case, I think it was a bit of a perfect storm as well, because of course, we're talking about a system that was being used across, even 10 years ago, 12,000 branches. It may be more, it may be fewer now, but we're talking about a system. Often these are sort of remote, rural, locations, maybe poor connectivity, mobile data connections being used. And of course, so this is a good ground to explore some of those edge cases, right? Certainly, it's a good system that you're going to be exploring some of those failure, hard to produce failure cases. But also, when someone goes in to use the post office, there's actually a limited time that you have available to complete this transaction, to complete this service. And I think when you're dealing with, I think there was an example of a failure happening and someone was allowed to leave the post office before really they'd had an answer as to whether a payment was complete or not. But of course, actually, you can't make a customer stand around indefinitely. And so when you actually have a limited time at which the system to reach a certain state, that introduces even more possible error cases into the system. You might be able to avoid some, but they can only be avoided if you have unlimited time. We have a limited time at which someone's prepared to stand at the counter. And so this means that, not only do we have certain possible error states that we will get into in this kind of distributed system, but also when we're dealing with that limited time window, there are a whole load more that we will get into as well. So it's I think obviously connectivity has got better, and now we're able to run some of these distributed internet-based systems a bit more reliably, but certainly these were error scenarios that I think the engineers should really have been quite taken care to document, let's say.
I kind of want to so this is kind of relevant to something that I've been working on for like the past year. Let me mute that. Sorry about it. I'll start again. We can cut this bit out, right? So that's kind of relevant to something I've been working on recently, and I think that you made a point there about connectivity getting better and that leading to better scenarios. But actually, I think that in some ways, this sort of internet being very fast and most people having like minimal latency when talking to each other has kind of led to people ignoring the fact that they're actually in a distributed system when they can just sort of pretend that they're not, because it's only 100 milliseconds, that's like a blink of an eye, and this leads to people just leaving out all sorts of things which would be very obviously needed if that latency was longer. So if you think back to like before the internet existed and the system that the post office used before, I guess it would be incredibly obvious when I'm like giving someone the money and the postmaster is writing it down, I just got this money on a log, that hasn't been like registered with the bank yet, that transaction has gone through in this location, but it is still pending finalization, because it is physically impossible at that time for it to have gone through automatically. But then when you connect it, people go, well, when I give you this money and you press enter, that's like finalized the transaction and this is all done and it's all settled, right? When obviously that isn't the case. And things like, in the UK, we have faster payments for doing bank transfers. You type in someone's bank details, you click send, and it says, sent the money. But actually, that's just a lie, because that could take hours, to actually fully go through. There could be a problem. You can never like guarantee that a message has gone through instantly. And so I think that we sort of see this still with mobile apps, because people go on planes, they're on, in areas when you use your phone where you don't always have good internet. So I find that mobile apps tend to like address these problems better, because someone will notice that, I sent a message and I was out of internet. So, you can't just lie to me. You have to tell me this message has been registered on your device, but it is pending, receipt, or however you show it. But I find that like web apps especially, and I guess a lot of backend systems too, people assume that they're like directly connected when they almost never are.
Yeah, it's kind of a fallacy, isn't there? That an example, whenever we, as software engineers, and sort of we're talking to someone that's maybe new to software engineering, and we're talking about transactions, and we have this example that people go to around, moving money from one bank account to another as a good example of how we're going to explain a transaction. Well, what we want to do is do both of these things as an atomic operation, so that they will both complete, and we can know that the money will never be in two places, it will never be in both accounts, it will never be in neither account. We will perform this transfer atomically. And I think the funny thing that software engineers always talk about, of course, is that this example is a complete fallacy, and that banks don't actually work this way. And so when we're talking about shouldn't we be building these systems at the same level of sophistication and correctness as banking systems? Well, banking systems aren't able to apply their updates atomically, complete these transactions atomically either. They require reconciliation. They require deep thought about the kind of error cases that can emerge.
Yeah, there's lots of manual intervention in banks, and they're not particularly inefficient, and certainly they don't have supercomputers that are always correct. But it does strike me that when this industry started, hardware was terrible, networks were terrible, things failed all the time. So certainly, but with those limited resources, people were able to build accounting systems that didn't lose money and that did work. And then then the relational databases happened, and the reliability of the mainframes were sort of that people had experienced, said, well, we need to get that reliability into our databases. And they came up with these kind of concepts of the ACID principles that we kind of mentioned. But then something, so in that short span of years, we sort of figured out some useful properties of systems that in guarantees at certain, at a limited level and at a local level. But somehow in the kind of rush towards distributed computing and the internet and Google and everything kind of being hyperscaled, and we didn't figure out how to recreate these guarantees. Certainly not in the 90s with Horizon, but I'm not sure. I'm pretty sure if truth be told, we haven't figured them out now. Right now, this is a concern because we're building the whole of civilization's IT on this very kind of this quicksand, and it's kind of this is a bit frightening. I mean, it's frightening on the level of cybersecurity and attacks to, electricity, power stations and all that stuff. We know that security is a nightmare, but actually not even getting some of the fundamental correctness primitives right is a cause for alarm. And it is one of the things that we should be, what can we learn? How do we learn from Horizon? It doesn't sound like we've learned anything at all, but what holds a glimmer of hope?
I think one thing that we know that we can't, the message we can't go away with, or that wouldn't be a useful one to go away with, is just that next time we should just do it right. We should just do it properly. Let's all be professionals about it and let's just do it properly. And, sort of saying, oh, well, this person, they were working on this system, they weren't good enough, and so they didn't do it properly. It feels like that we need to actually talk about what it is specifically that we're talking about when we say doing it properly for this kind of system. Something that you had mentioned earlier today, Alex. So I think the software industry has always been very resistant to formalizing what doing it properly means. And I think because, we see software engineering as a whole wide gamut of different things. And so when we talk about, well, every system should have these properties, then there's always a counterexample when we think, oh, well, what if I'm working in a startup and I'm just trying to sort of throw things together to prove an idea quickly, and it doesn't need to work right. It's just a, quick validate the idea and then move on. I don't want to be held back by those kinds of things. So, but it does imply that maybe there are certain kinds of systems and certain subparts of the industry, whether they're, regulated by certain bodies, where we should come up with some, hard and fast rules for how we build things. And what I think, we do, of course, have regulated industries and we have certain standards bodies. It seems to me, though, like a lot of what we have at the moment addresses more process than it does technical characteristics. So it may be the case that we're in a regulated industry and therefore we have to have a certain development process and we need to have checks and balances to prove that we're following that process. But the specifics of what that process must be are kind of left to the reader. But we need to satisfy that we have the checks and balances to know that we're following our defined processes. It does seem like that there is potential to start laying down some of these fundamental technical characteristics.
The problem,
but so I'm interested in what people's thoughts are about this question of what are the rules and how should we, let's assume that we're working on a critical system of this nature. What might we propose as what it means to do it well?
Sorry, I can't help myself. But it's very rude to interrupt people. I couldn't help it. What academia says as an answer and is a right answer. I like semantically, it's a complete answer. Mathematically speaking, it's the right thing to say. Use TLA plus, which is a modeling language. Build a model of what your promises are, what your expectations are, and then it will check whether the model of getting from point A to point B is correct or not. It will give you that, right? It's written by the grandfather of distributed systems called Leslie Lamport. It's the bee's knees, right? I personally, and this is my personal opinion, this is important to stress. I think it's overkill for something like a banking application. For Horizon, for something like Horizon, it would have been absolutely mandatory, right? I get that. But the problem with DLA is that it's a model of a model. And if you build it can't run your code, right? It can run a model of your code, which is very useful for big enough projects, but it means hiring the talent, which is mostly means math PhDs, but at least computer science PhDs who have specific understanding about combinatorics. They must understand these things before they can start building out these models. But also the what they will give you, these people are not usually practicing engineers, right? These are sciencey people, right? Like I'm painting very with a very broad brush here, right? So bear with me. But the point is, the result of their work will not be code. It will be the model of a code, which will have to be translated by engineers into the code and put it into Clojure, Spring, Python, whatever real environment that it will be running in, right? And there, the potential for failure rises again, right? So even though your model might have been fine, and it's great to have, if you're running something like Amazon Web Services, you absolutely must do that. I get that, right? But for a microservice project at a bank, um, this doesn't sound like a feasible solution to me. Having seen the sort of resources that we had to work with within investment banks, mostly, right? So I think what I do is do quite a bit of modeling. Sometimes I go all the way to TLA, very rarely. But I personally just do a lot of modeling and kill it with stress testing any occasion I get. Stress test, stress test, stress test, with as many threads as the computer can bear, essentially, and
Yeah.
simulate user behavior as closely as we can. Sorry.
Yeah, one of the things that wasn't obvious with the Horizon system was that the level of testing that they had. They had some sort of remote machines or dummy machines or simulators, but they didn't have the kind of level of stress testing that we would kind of want today. Another thing is, I think it was an accounting grade application. From a risk point of view, there was, I suppose, the team probably didn't realize that these sub-postmasters were legally liable for any losses, and therefore that put the onus on the software to be correct, and where DLA plus and that approach probably was a good candidate. Although I accept, most applications we write, social media applications or applications to run your exercise bike, it's not the end of the world if it doesn't add up the calories quite in the right way or loses, a few, a few of your kind of heartbeat measurements. But it does matter when you're dealing with if you were legally liable for the kind of financial loss. And so I think there does need to be some sort of distinguishment between where applications that are in that class ought to be subject to some kind of audit or some domain, some sort of scrutiny from some, I don't know. I mean, I know there are sometimes you can have a government legislation and regulation. Sometimes it's the industry, like in the credit card industry, there's the PCI DSS, which is kind of, all of these, except Joe, are process driven, like we've got risk, but we've mitigated the risk because we have a risk committee that meet every month, and that's the way. But I think we shouldn't throw away the benefits of actually looking at process. Processes are very, very effective, and in the aeronautic industry and space industry, process has been proven to be really a good, effective tool. So we shouldn't throw the baby out with the bathwater. But the technical characteristics of the system that you mentioned, Joe, being able to say we can. We have a high degree of confidence, 9.99, something or some uptime measurement or something, which you could then you would then have to open source and say, look, we invite researchers or hackers to come in and prove that this system isn't up to this grade, and therefore if they do, then you either get a bug bounty or you get some, there does seem to be a missing alignment of incentives here, which so if Horizon had been open source and there had been a bounty to say anyone find a bug in this system, you get a monetary reward or something of that nature. I think might have helped.
Yeah, I think the it's quite common, isn't it, to have clauses in a contract that are unenforceable because of some the characteristics of the goods that you've provided, or the the something that relates to the contract that makes certain clauses unenforceable. And it does seem that when dealing with software, if you want to have a clause in a contract to say that a user of this system is responsible for any discrepancies in the data it produces, that does seem like you could have a technical requirement. If you want that kind of clause in a contract, it can exist, but only if your system that meets certain criteria. I would argue that being a distributed system by definition should mean that criteria is unenforceable within a contract, because as we know, as we've already talked about, it introduces a whole load of possible errors that actually cannot be resolved unless by investigation. But as you're saying, if you could decide that actually, if that kind of if that kind of contract is present, then the system in scope must be implemented using some sort of formal verification methods, like as possible with a system using TLA plus. So that could be one example in a way of a concrete change to say that actually that kind of clause is no longer legal unless the system meets certain technical criteria.
I think another thing that sort of building on that came away from watching this was how blind the general public are. And by general public, I mean basically everyone not technical. So the postmasters who are working there, like the people at the post office, the people in the court, the judge, these people, because this takes a really long time to learn, do not have any sort of understanding how systems in general work, let alone like complex distributed systems like Horizon. So I wonder if there also should be, as well as open sourcing like the core parts of any accounting or that sort of system, so that other technical people can peer review these things. I wonder if there also needs to be some sort of legislation or like guidance on exposing what is happening in such a way that the general user of the system is able to actually understand it a bit better. So, for instance, if we have a simple messaging app, then we might have a requirement that says when I type a message and click send, it says message, WhatsApp or whatever will say message sent at this time and then received at this time and then read at this time. And you have like these different timestamps for where these different events happened in the system. And my mother can understand that. That's pretty easy. And you could imagine in the post office system a similar thing could be done, where I've typed in my transaction and it's been registered on my local Horizon machine, but then the transaction has failed because the power was cut and it never synced to Horizon, and this sort of thing. Obviously it would be, step one is like get that into the logs, get that into like some open source code base so that people can verify it. But I think it's also important that the user knows what's going on or can sort of see what's going on, because then maybe we can avoid all of this and we don't have to go to the courts, and we don't have to have people like stressed out that they've lost money, because they can see, oh, I haven't lost money, it just didn't get from this stage to this stage.
So one of the things Nathan Martz talked about was deterministic. He was mostly talking about testing, from what I remember. My solution actually takes this a step further. It's deterministically reproducible. That's how it does replication, and that's how it does what it does. And that's how it can't fail, because you have multiple copies of it, because it's deterministic. So the idea that, and this is how I actually started talking with Stephen Murdoch, because the idea that you could make computer systems which handle money traceable to all the causes that put the eventual result together should be a big step, because even if the system isn't perfect, at least we can trace it back on where it made the error, right? So we can take a step back and say, well, it's not necessarily true that all we have is a constantly mutated state of a machine somewhere. It's entirely possible to trace all the reasons back to their origins, right? And if it's about someone going to prison, then they most certainly should trace those things back to their origin, right? So that's one of the things that I think could help. Deterministic testing, as I fully agree with Nathan on that. I practice what I preach on that, what he preaches on that too. I think it wouldn't be a big ask to say that financial systems should be deterministic, because they should be. Because I understand that it's a big ask with the current tooling, but it's technically possible, and it would help immensely with all the aspects that we just discussed.
Could you define deterministic? Just
That's a very good question. Thank you very much.
Given that you're going to send people to prison for not doing this,
Oh
we have a
God!
definition.
Yes. Thank you. That's actually well. Everyone has their own definition, right? My definition is that the internal state of the machine is entirely the result of the inputs it was fed, right?
And can be recreated.
And can be recreated at will based on a particular offset. So you say replay it until this point, and then it will give you you can replay the computer to the same point, and the computer will be in the same state as it was when it served the wrong answer, say, right? So you can test those things locally and reproduce it as many times as you like, right? You take away multi-threadedness that way. You take away race conditions, because race conditions are original information being created. So that's a big thing, but that means you have to create your own consistency between these various streams, right? This is a very, very deep rabbit hole that I've been digging for the last 10 years. I don't want to take you guys down there. The point is, I'm saying that it's possible, and this is what my innovation is about. This is the reason I left the city to work on this, right? To help the city's data problems. That was actually the reason I left.
And it's a very hard thing. I think we want to give you a plug, which is the Andreas's website is omniledger.io. So you want to kind of dig into some of these thoughts that we don't have time to cover. I'm hoping that we can do another podcast to cover the more deeper aspects of determinism and distributed consistency that we've touched upon. But I do want to respond to a couple of things. Joe, I do like your kind of point about it needs to somehow match up to the contracts. Ultimately, law is practiced through these kind of contracts, and it almost asks for a specialist type of lawyer to be able to review a contract and say, well, actually, that's not a fair thing to ask of a sub-postmaster without back-to-back this contract that you might also have with Fujitsu. You have to have these guarantees. Just so to have lawyers who are versed in some of the properties of systems and distributed systems would be great. Where do you get those lawyers from? I don't know, but I think there's a lot more AI being applied to legal contracts to read them and to spot kind of violations. I think that holds promise. I also want to touch on respond to Alex's point, which I thought was excellent, around the explainability of a system, which we call provenance, which is tied to determinism, because in fact one of the clear things from the ITV drama was that many of the sub-postmasters were saying the system is just telling me I owe this amount, and there's no rationale or explain. And people don't mind things as long as you get explained, right? Why is there no food tonight? Well, because, right? Why was the train late? Well, because the staff member didn't turn. Well, anyway, those sort of excuses. I mean, real explains where you, as Alex was saying, you can say this happened because of this and because of that and because of this, and you can give it to a lawyer and they can explain it to you. Even if you don't understand the explain, at least you've got it, like a stack trace or something, some evidence. But the fact that this stuff was missing, and the logs were not there, and but I really feel that explains are a missing part. We don't value them as much as we should, and even to the point it's going to get worse, because we're going to ask, well, why was this particular person executed by a drone, and you'll say AI just decided, I don't know, and this lack of explanations, I think, is a massive thing that we have to hold our hands up to in the industry. How do we make our systems more visible and explain themselves better?
Well, I actually think, just on your AI point, because obviously that's topical at the moment, I think that doesn't actually stop what I want to happen from happening at all, because all I want to happen is that everything is clearly documented and there's a process, and then that forces you to understand how explainable each process is, because not everything is explainable. There's plenty of the laws of physics that we thought were fundamental, and then we sort of, oh, whoops, that's actually not right at all, and that seems to be happening all the time. So we basically know that we cannot explain everything, and there are always going to be things that are sort of unknown to us right now. But as long as we say, this happened, and then because of this we did this, and then because of this we did this, and there's a log of like the current understanding to the best of our abilities, then that's so much more than what they had on Horizon. And I think we should do whatever we can to move in that direction, because even if AI says send that person to jail, if there's like any sort of log that's like, oh, the AI said send that person to jail, and someone just sent them to jail without like doing any sort of other check, then you can at least start to blame people based on that. So.
I think I think we may, like, to my mind, have hit upon another one of these rules of what does it mean when approaching this kind of system to have done it properly, and what are we going to, specifically, how would we hold someone to account if they were building this system again today? I think this idea that actually the user has a right, not just an expectation, but a right to see the actions that they've taken, to understand if they've made a mistake, and for any value that is derived, to understand how it's been derived. And this actually should be a minimum standard, in the same way that we start to build up expectations around any computer systems, if they're functioning correctly. I think there should, the users of this kind of system have a right to be able to understand what actions they've taken, but particularly, and I think, another problem in the case of Horizon is not only were there times where these totals were being arrived at, but it was not possible to see how they were calculated. And so, if you accidentally miskeyed 500 as 5,000, well, tough luck, because that's now, it's now telling you owe 20,000 and you don't know why. The other thing is that where there was some, records available to the postmasters, there were initially cases where those records were only available for 42 days, and then this became 60 days. These kinds of time limits are not acceptable. When we are talking about this kind of system, sometimes these problems take months to resolve, and it's important that people don't just have, sorry, you can see the data for 42 days and then it's out, then it's hidden to you, and now you can't see it anymore. That kind of thing is unacceptable. So I think being able to provide information to a user about what actions they've taken is something that we actually should be adopting as a fundamental requirement of this kind of system, a specific requirement. There's two sides, though, isn't there, to auditing? There's the kind of auditing so that the user can see what they've done, and then there's the auditing so that forensically we can always piece together every action that the system has taken. And it does seem to me like, and we know in the auditing, the logs and things like this weren't adequate at certain times in the lifetime of Horizon, but it does seem like, I think about this similarly to like highly available systems. We talk about highly available systems, systems, cloud, often cloud systems that we try to eliminate single points of failure. And so we can look at a system and just, we have the terminology. It may not mean the same thing to everyone, but we can kind of throw around this idea. Okay, that system, that's HA, and we all know what that means. Or we roughly know what that means. I kind of think that we need this notion of an HA system which is a highly auditable system. What does that mean, a highly auditable system? Because it means completely different things. At the moment, it means different things in the industry to different people. It would be great if we could get to auditability standards, and it does seem like, in a way, this standard of auditability trumps everything else, because it almost doesn't matter, if we haven't really come to an agreement yet on formalizing the model and how it should be tested, then that's an issue. But if we haven't yet come to an agreement on the auditability, and that's a serious problem. And in a way, the auditability is the backup strategy for everything else, so that we can see what's happened. So I do think we could arrive, particularly in this kind of system, we could arrive at some common agreements of what is what is a highly auditable system.
Yeah, I like this idea of the kind of a right to an explanation. I mean, GDPR does have sort of similar rights, and in the right to be right to erasure, the right to object to your records being processed by a computer, and they don't really hit the mark that we're looking for here. I mean, they're things like the right to object to an automated decision, but actually, what people want is a right to an explanation. It doesn't matter if it's human or automated. Why did you refuse my loan? And why have I got a bad credit score? And what can I do to rectify it? I mean, without the why and the explanation, you then you don't have enough. And I think that whether it's a court or this ability to put in explanations, and I don't know if there's actually more than just one being more coarse grained. I don't know if we want systems that have two explanations, one for the techies and one for the user. I think like the user just needs a more aggregated summary and has the right to drill down and the right to bring in their experts and to like, give me the entire stack trace, please, even if I don't understand.
I think this goes back to what you initially said before we started recording, Malcolm, which was that people are more and more exposed to the sharp end of our systems. Like it was all fine and dandy, back in the early 2000s when we were mostly just playing around with technology. But nowadays, it rules your life to such an extent that it should be a question of human rights, in a sense. Like you can't live your life. Like, if I lost, like, this sounds banal, and I'm sure people will laugh, but if I lost my Google account tomorrow, I would be in proper problem. Like, I would have, like, and Google can do that like that, right? No explanation, nothing. But it has such an impact on my life, my access to that account, that it should have some sort of a, like you said, it should have some explainability.
I think this is key because I was listening to the Spike podcast on this topic recently, and it was really saying that because computers are so impersonal, what really captured the public mood was the fact that everybody feels they're in the Horizon system, they're using the Horizon system. Everyone feels they're staring at their phone, or that Google have cancelled their account, or their identity has been stolen, or they're on the phone and the bank has rung them up about fraud, or they've got some security virus, or somebody's rung them up from India and they've been told that their computer is a virus. Everybody's subjected to this kind of abuse by computers. In the old days, I mean, if the bank made a mistake, you could go to your branch and ask to speak to your bank manager. There is no there's no analog to that in Google. You can't just go to California and go to Larry's office and knock on the door and say, I think you've made a mistake. And because there are not there's no safety net, people feel exposed to the vagaries of a decision made by a computer. And that, I think, is what really people are objecting to, and why they're so sympathetic to these sub-postmasters.
I think as well, in a domain, this kind of domain, when a computer system is entering this kind of domain, if we think about, where is the bar on auditability and being able to go explain what's going on and being able to keep records, it's very, very high. I saw a history program the other day. I was watching it, and they were talking about records from Rome, that we have that explain the kind of financial accounting that was going on in Roman times. And actually we have we've been able to get some documents. These are 2000, this is a record that's 2000 years old, and people can actually understand so what was going on accounting wise in Rome. So that is a very high bar. So if you're going to get rid of a paper-based system that's producing the kind of physical artifacts, you really better make sure that the system that you're deploying can meet that level of longevity, auditability, that really, that you can give that kind of insight to both the people on both sides, the people managing the central systems and the people, the users, that they can really audit it. And I think that anyone that's entering that kind of realm to replace paper-based systems, it may not be efficient to audit those kinds of physical logs. But I think we should just have a lot of respect for how the kind of longevity and auditability that they provide, and really attempt to provide the same.
Yeah, absolutely. Any closing remarks? We've just got to the hour, and I just want to see if we've got it. What lessons can we learn, and do we need another episode? Are there? I think what we just to sort of review, we have kind of decided that there is a need for having some formalistic or formalisms of certain technical characteristics that we can define, like determinism and provenance. The ability to explain what's happening. We've touched upon these are very technical Boolean principles. They're either there or they're not. Or I suppose in the explanation, that there is a kind of extent to which you can't explain everything, but to have much more evidence in a system for being able to object and say and ask for a review. And we've touched upon kind of how officious computers are. But are there any more learnings that we can dig in? And are there some socio-technical learnings that we can do as communities? For example, is professional qualifications. I think we talked about that before the podcast. What would be the value of technical qualifications of people building this software?
I think one sort of thing that I would like to have people go away with, if you like, or one thought that I'd like to have people go away with. I don't want this to sound like a flippant remark or something that doesn't take people's situation seriously, but I really would appeal to everyone in the industry. If you think that you're working on a system for which these kinds of problems exist, and you think that users are being treated unfairly, then talk about it as much as possible. And if you think that there are errors in a system and that they're fundamentally, now I'm not saying in any way that that wasn't happening already on the Horizon, the Horizon system, and that people weren't being ignored left, right, and center, and people were shouting about it. But I think it's the most, from the software engineering perspective, the best that we can do is look at a system like this, be honest about where those failures exist. Don't feel embarrassed about them. Some of the the things that we've talked about, they are essential errors that exist in the technical things that we produce. They're necessary. And I think I would just encourage people that if you feel that you're in that situation, it's a very noble thing to do, to shout about it as much as possible.
But Joe, do we need because I'm reminded of in the drama there was a conversation, I think, in a cafe of one of the developers who came forward at first anonymously and then was coaxed to having to go to court. And the reason why they were so hesitant was clear, that they knew that the post office were a pretty evil operation, and they were going to go after that. And so, do we need something akin to a software engineer whistleblowers charter or some sort of protections for IT whistleblowers who say, we are not securing our system? Because I've been in systems where we've made certain, management have said, oh, this system is secure, and no, full well it isn't, and have lied to the auditors. Do we need something of that nature? Because these systems are incredibly complicated, and if you're working on a system, if you're a software developer, as we've all been, that you're under 18 levels of management sometimes, and even if you do put your hand up, it might not go at least even beyond your line manager. So we just have to be we have to be cognizant of that, and maybe we do need some kind of legislation to allow people to raise red flags.
Yeah, I guess not to open a massive can of worms so late into the podcast, but you could argue that like it's sort of human nature that humans will always lie and try and do whatever they can to get ahead personally for power or money or whatever the reasons why. And so the only real answer is that if you have something which lots of people depend on, and it would absolutely mess up their lives if it was to go wrong, is to make things public and transparent as possible, in the various ways. And I guess that's why things like the blockchain and all of this sort of cryptocurrency stuff has gotten uh, both a lot of fans and a lot of governments or organizations sort of not wanting it to happen, because I think earlier it was mentioned that you could go down to your local branch and you could ask your bank manager and they'd sort out any problems, whereas nowadays like that never happens. Is that actually because of technology, or is that just because businesses have become more cutthroat and they're able to get away with that sort of thing? And there was another scene in the drama where they requested information and the post office printed off like a 100-page sheet of all of the documents, but with every single line blacked out as like this sort of yeah, like that. Just because there's laws in place to allow for freedom of information or like requesting data, companies are always going to try and worm their way out of it. So maybe the answer is to have a sort of more open, decentralized system and investigate more on those sort of things. But I guess I'll leave that as an open point.
I do have one more philosophical point to make, but as per usual, I think there's an inherent trade-off in these systems of people governance versus technical governance, and centralization versus people management, because it's the pizza box, the two pizza box size team, which is like the agile thing to do. It does make sense, but it makes sense on a very different human level, as in you want to manage a group of people separately who have different responsibilities. But then there are other people here who have somewhat overlapping responsibilities as these people here, right? And so what I'm getting at this very circumspect way is that we always have to make a choice on how much correctness we expect from the system and how well manageable the system is, because we can't have a multinational bank running off a single Oracle instance, right? Or Postgres or whatever, it doesn't matter. But you just can't do that, right? Not technically, but then that also brings in all the things that I talked about earlier, which is the complexity just blows up almost immediately. So where do you draw the line? I don't feel like I have a good answer to these questions, right? But what I'm saying is that we have to be, if we're going to talk about, if we're going to put ourselves into a position where we feel like we have something to tell our industry in this aspect, we have to be mindful of these different considerations they need to make, right? That's I think the
Yeah,
bigger point.
I agree with that. I don't think we have any clear cut answers to the problems. We know that we are dealing with complexity and it's moving in the wrong direction, and we're trying to kind of, even rescuing things like explanations is becoming harder and harder to do. And I guess let's not give up hope. Let's go and research and spend time and spend the on some potential technical mitigations to these problems. And I don't believe that we've got all the answers, but I believe that those answers are out there. And if we can objectify them, if we can continue our search for knowledge and improve the practices, and I mean, I think there's some amazing things that we have learned over the years in computer science. You mentioned distributed ledger. That would have been pretty useful in we didn't have anything like that. We didn't even understand hashing or Merkle trees or those sort of things in the 90s. They were very, very academic subjects. So things do improve, and yet there are some absolutely savage lessons to learn from Horizon, and perhaps there's many other Horizon IT scandals in store, in the future. And it really isn't enough for us to say that, shrug our shoulders and say, well, we'll try and do a better job next time. There's some really important things for us to learn, and I think we touched on some of those things in this podcast. So let me say thank you very much for all your time, everybody, and particularly to you, Andres, for joining us as a
Thanks
guest.
for
And we
having
hope
me.
you can have you on again. If you want to, a plug from our sponsors, I suppose. 3 out of 4 of us work for Juxt, and we definitely believe in not shredding data and editing data in place. We believe in immutability and immutable databases, and we have a database at xddb.com that is just coming out with its version 2 and very exciting for us. So we'll probably be talking about that in another podcast. I know that you've got a podcast idea coming up, Joe, that you're going to do soon on the subject of waste, that you've had a blog that a very, very successful blog. Do look on the Juxt website for that blog of Joe's. And Andras's work is at omniledger.io. We'll put a link in the show notes, and also to Andras's blog, which is how I know you, Andres, through kind of being an avid reader of your many excellent articles on Medium. So we'll put a link on there to Andras's blog as well. Just leaves me to say thank you very much. Enjoy the weekend, everybody. We'll try and get this podcast out as soon as we can, and we'll sign off. Thanks very much. Good night.
Thank you.
Cheers all.